All right, thank you. All right, so you're welcome back to the training. And as you notice, I think this is one of the sessions we are most But I already want in the morning. You don't know Python, you don't know people. Okay? You cannot write Python program, forget about graduate. So I need to be as excited about everything that you see. So Mr. Patrick Davidson to continue in what we started yesterday. He's going to have specific instructions for you before the training starts. I'm just going to hand over to him right now. So can we welcome Mr. David Patrick?
Hello, good afternoon. Good afternoon. Yeah, I updated the Google Drive link I sent to you guys yesterday. I want you guys to download the zip folder that is there. This is named Day 3. The Google link drive I sent to you yesterday. Check for the folder and have someone in your group download it. Also, some of you guys are not able to use your release yesterday, and I promised to show you guys how it was going to work today. If your group didn't see how it was working, I want you guys to come one by one, starting from the group here. Yes, sir. All of you in your group should come see how the relay works and okay. All the groups that didn't get to see their relay work yesterday, I'm calling you guys one by one to the table to come so I can show you how it works. Starting from okay, the Google Drive, there is a file on the Google Drive named Day 3. You guys should please download that file. Day 3. Day 3. Is zip file. Okay, so this is. So yesterday we had issues with our controller because we said our controller could not. Yesterday we said our controller could not trigger our relay. So this is what happens. This is an Arduino Uno. It has the capacity to trigger this particular relay. It's higher than this physically, but on the inside, this has lesser memory than this, but it has more physical capacities. It has more voltage, more current. So if you plug this guy in, your code yesterday was supposed to do this. If you plug this guy in, your pump should be working. That means that there is no water. Touch it. That means that there's no water. And when there is water, your pump should go off. That was what was supposed to be yesterday. So when there is no water, your pump should go on, and when there is water, it should go off. That is what you are saying. All right, thank you. Next group, please. Yeah, I don't know. This group. Yeah, next group. Yeah. So for us that were around yesterday, you remember that I told you that our controller cannot power these people, cannot trigger these people. Now this is called an Arduino Uno. It has more physical capacity. It has more physical capacity than your people. It can deliver more current. So your code yesterday was supposed to do this. When there was no water, you should have your pump working. Hold the pump. You should have your pump working. And when there is water, your pump should trigger off to create an automatic system. So when there is no water, your pump, then when there is water, it should trip off. That is what your code was supposed to be yesterday. Thank you very much. Next group, please. Next group, please. Yeah. Why you are present yesterday? I remember I told you, sorry, yesterday I told you guys that your controller did not have the capacity to trigger this relay, yes? Now this is called an Arduino Uno. It has more current capacity than your Pico. So this, if you upload your code on something like this, this is what it's supposed to do. When you have, once there is the presence of no water, your pump is supposed to work. If you hold it, you guys should touch it. You guys should touch it. Your pump is working, and when it sees water, your pump is supposed to go off. You can see your pump goes off, then it goes on. That is what your code yesterday was supposed to do. Thank you very much. Next group, please. Recall yesterday I told you your Pico do not have the current capacity to trigger this kind of relay. Now this is called an Arduino Uno. It has more current capacity than your Pico. So if you upload your code on a Pico, on an Uno, you should have something that works like this. When your sensor sees no water, your pump should be coming on. Touch it, your pump should be coming on. And it should work, your pump should work. But once it sees water, it should go off. That is what your code yesterday was supposed to do. Thank you very much. And then last group, please. No, the other group, the other work yesterday. The other one, the one at the back. No, the one did not work. It's the one at the back. It is the one that worked yesterday. This is the one that worked yesterday. So yesterday when I was telling you guys that this guy does not have huge current capacities to trigger this relay, yes. So this guy has high current capacities than your Pico. If you upload your code on something like this guy, you should work this way. At this point, it is giving you no water. Your pump should be working. Your pump should be working, and when there is water, it is supposed to go off. It went off. That is what your code was supposed to do yesterday. It's pumping, like the pump works. There's like a motor inside. If you put it inside, hold on. Is it this way or this way? You see water come out. You should see water come out. There's a way you connect it, probably from top or from the side. Either way, water will come out. You can't find the file on the link. So they said they don't have a buzzer there. Hold on, they are coming, they are coming. Okay. Sorry. Look at that plus. See where the plus is. Okay. If your buzzer doesn't have a longer leg, on top of the buzzer, there is a place they wrote positive. You see a plus sign if your buzzer doesn't have a long leg. That plus sign is your side. So use that instead. Let me give them this one then. But I give them buzzer. One. Let them check it. All right. You guys understand how you are connecting it, yes? Do you guys understand how you are connecting it? You can connect your buzzer directly to your breadboard. You can connect your buzzer directly to your breadboard. And remember, when you are connecting your buzzer, you cannot connect your buzzer like this. You remember you cannot connect your buzzer like this. Because all these places are connected, you cannot bridge the buzzer, so you can connect it like this. So you can connect your buzzer directly to the breadboard. The negative side of your buzzer is taking ground, and the positive side is taking V-bus. Your V-bus gives out 5 volts. Please connect your buzzer that way, please. We have that. Okay. You can connect it directly to the breadboard if it's not going to enter very well. Each side is your positive side. Just plug it this way. Might bend a little though, but don't worry about it. So here's the positive side. This is the positive side. Look for where the leg is entering and plug it inside. So that way it's easier. Okay. The positive side is this plus side. So make sure that when you are connecting your positive side, it is aligning with the leg of where the buzzer is. So once you plug in your buzzer, where's your people? This is your positive. You guys should come up and look. This is your positive. Your positive is going to any GPIO pin. This is positive. And then your negative is going to your ground. This is your ground. Look at the legs. You see the legs are aligning. You can see the legs are aligning. So this is your positive, this is your negative. Your negative is going to your ground. Your positive is going to any GPIO pin. If we need to change this guy to male to female, yeah, change it. Any other groups having issues? You guys are connected, yo. You can connect. Hold on. You can connect your buzzer directly on the breadboard. You put it directly on the breadboard. Just look at where the pins are. You have to bend it a little. Just look at where the pins are and connect it that way. You get? You understand? You guys are connected yours, yeah? Sorry. Sorry. Okay. You guys understand that you're going to connect it, yes? Okay. Okay, this is fine. Yeah, this is fine. Here's your positive. You pick any GPIO pin and you pick your ground to ground. That's fine. All right. All right. Have you all connected our buzzer? Yes, sir. Yes, sir. And then you have pin, yes. Have you all connected our buzzer? Have you all connected our buzzer? Have we all connected our buzzer, please? All right, let's go to our Tony. You any GPIO pin that you want. Wait, the second leg of what? Positive is any GPIO pin, negative is ground. All right, like yesterday again, you are calling our pin functions. Remember I spoke about PWM yesterday. Who can tell me what PWM means? Pulse width modulation. When you are dealing with analog components, you are either running it. You are either running. Hello, it's not working. Hello. It's not working. It's not working. Yeah. Hello. What's saying? You are. It's not working. It's not working. It's not working. I should continue. They can't hear me. You are either running it as ADC or PWM. ADC means analog to digital conversion, or PWM means pulse width modulation. So we are calling from our machine. It's not okay, it's working now. So we are calling from our machine. We are calling the pin function and we are calling the PWM function. Pulse width modulation function. Then we also want to import our time. Who remembers what our time? Who remembers what our time does? Who remember what our time does? Delay, that's very good. Delay. Now let's create a function called buzzer. And we assign it to pin. Okay, PWM 14. Yeah, I can't find it. I dropped it somewhere. PWM pin 14. So PWM pin 14. So can you all see my screen, please? Can you all see my screen, please? Okay, it's fine. All right. So you pick any pin of your choice. Any pin of your choice for it might not be 14. Pick any pin of your choice. All right, let's run our code. Now, to explain this code, what I am saying is, usually every component has its own set duty cycle. For components like buzzer, some of them might not be able to handle more than 1,000 duty cycle. 1,000 duty cycle, unlike components like your variable resistor on your table. These ones can do higher duty cycles. But now, so I want to have my buzzer play a tone. He plays a tone at 300 duties. He plays a tone of 300 duty cycle. I delay a little while. He plays nothing, and I play a tone of 300. Okay, switch the tones, switch the duty cycle. You can have probably play a tone of 800 duty cycle here. How many of us are done with typing our code here? Remember, I said the frequency is the pitch, the sound, how loud it is. Your duty cycle is how long it's going to be active for. So we are running a duty cycle of 300. We are waiting a while. We are running nothing. We are waiting a while, and then we are running a duty cycle of 800. If you play it, you should hear a difference in the sound that your buzzer is making, please.
Different sections where the code is doing something different. So you can add a comment and you put a new anything line in between. So in this first 3 sections, doing this. In the next 2 sections, change this comment and a line break.
Yeah, please, I made an error. That U16 stands for 16-bit strings. U16 stands for 16-bit strings, not _16, _U16. (16-bit strings). That means 16 times 4094. If you multiply that, you have 65,335. 65,535, sorry. Or around that value. No, that's the maximum value that people can handle. That's why I say U16. Is our code running, please? Is our code running? No module name. Yes. Let me see that. No module name. Machine.
Oh, you are not connected. Check.
Hold on.
Precious.
One moment ago, okay, I've not changed
Okay. You can increase your delay to 1,000. If your buzzer is sounding, can you hear the difference in the tones? Can you hear the difference in the tones of the two sounds? You guys are connected. Have you connected? Yes. Okay. Change your this guy. It's not showing. Which this was on the PCs yesterday. Save it, close it, and open it again. It should show. It should show. Duty cycle is 800, please. 800 and 300. You can increase your delay to probably 1,000. I'll run it again. Can you hear any sound? Check very well. Hold on. Yeah, there's a sound. Yeah, increase second delay to 1,000. There should be a difference in the sound so that you can hear it clearly. Run it again. The sound might be very faint though because of the noise and everything. Can you guys hear the sound? Everybody, we want to use this buzzer to play a little music. We want to use this buzzer to play a little music. If you check the file I sent to you, I created a PY file called buzzer music inside. There is a buzzer music PY file inside the zip file I sent to you.
This is positive side, this is negative side.
Okay, GPR pin 1. Is that?
That's the positive.
Okay. Here's the code. Code.
Okay,
Duty on that for U16. You can increase your delay a little bit so you can have 1,000. So you can hear the sounds, the different sounds more clearly.
200.
Sorry, 1,000 buzzer frequency. Run it again.
You understand?
You understand, yeah. What's it?
Where's the last?
Okay, that is this guy. Let's run. Did you run? You can. As all the group, is your buzzer sounding? Or do all the groups or their buzzer sounding? Yours is not working. Okay. 16. Okay, let's try to increase the delay a little bit. 1,000. Okay, right here. Okay. Okay, hold on. Let me plug it directly to this guy. Plug it directly to this guy. Okay, give me this is ground. This is ground. Then I have GPIO 0. Now you can hear that faint bit.
So the contact was bad.
Yeah.
I guess they're the only ones connecting by jumper cable.
Yeah.
Initially.
Yeah. All right. All our buzzers beeping. Now open the zip file I sent to you guys. There is a file called buzzer music. There's a file called buzzer music. This is what is inside the file. All right, I'll explain the code. I told you we have a little bit of complicated code to do today. I'll explain the code to you guys. I'll explain the code to you guys. Just calm down. Because that's the maximum frequency it can handle. Because of no, not the pico. The buzzers. The is not loud enough. That's how passive buzzers are. Or like active buzzers, it has higher frequency. This guy can only go faint and this thing, or else it will not. No. Try 10,000. Try and find out. Try and find out. Just. I use 1,000. You guys learned about lists this morning, yes? You guys learned about lists this morning, yes? Now I want to include something called dictionaries. It's a type of list. The only difference is it has elements called keys. The difference between a list and a dictionary is this bracket. This bracket in a list you have square brackets. Yes, remember? In a dictionary you have curly brackets. Yes, you guys are done. It's not working. I should share my screen.
What you actually change is frequency is different. This frequency has changed there. I thought I changed.
You guys are done. You guys should play around with the frequencies. The frequency on the code, on the previous code. You guys try to give your buzzer to play different frequencies and hear the difference. Trade the values of your frequency, manipulate your frequencies, give your buzzer different frequencies and hear the difference. Is it working? Okay, hold on. Maybe you should try frequency of 300 and 1000. Okay, not this file, the previous code that we're doing. The previous code that we're doing. Yeah, play around with the frequency. Let me give this guy, say 200. And another frequency of 1000. Try to hear the difference. It's still not working. Okay, import name. Okay, no, you can't import the name pin. It is pin. PWM. You can hear it. Okay, now let's try to play around with the frequency. Okay, say I give this guy 200. You can hear that difference. So we are okay. Let me delete this guy a little bit. I'm coming so you can hear clearly. Control V. So this guy to 1000. And this guy to 1000. Again. Indentation. You can hear that sound? You can hear that sound? Yeah. So you can hear the sound, the difference in sound. Add a delay after that duty cycle of 800. Add a delay after that duty cycle of 800. Add delay here. You should hear two different tones. Two different tones from your buzzer. Two different tones from your buzzer. You guys have it. All right. You guys have that. If you have it, you can play around with different frequencies to test the sounds. Can you hear the difference? Ron, can you hear this? Yeah. Don't shout. Let me know. You can hear two different tones. You guys have done it. You can play around with the frequencies a little bit. And I want to use that frequency. I want to use those frequencies to play music. Every frequency has, on your tonic so far, do, re, mi, fa, sol, la, ti, do, actually has a particular frequency. Those are the frequencies I set here. Your do has a frequency of 26.31 down to, I listed all these frequencies here. We want to use those frequencies to play music. I will explain the code. You guys, you don't need to type it. I sent it to the zip file. If you download the zip file, the file is inside. The file is inside. Buzzer music. Buzzer music. The file name is buzzer music. You can open it with your Tony. These frequencies are the set frequencies of everything on your Tony so far. Do, re, mi, fa, sol, la, ti. Like your T has a frequency of 493.88. We use that to play a music now. Now I put all this to explain the code. Are you guys listening? Are you guys listening? I put all these frequencies inside something called a dictionary, like a list. What's your dictionary? The way your dictionary differs from your list is that I can assign, okay, if I have a set of numbers, I assign C4 to 261.63 so that I don't have long numbers to call it when I need it later. So I assign values to it, C4, C sharp, D4, D sharp, and I called my buzzer number. This is my PWM. This is where you change your pin number to the pin number of your buzzer. And then you set a duty cycle. Try to use 3,000. The thing about duty cycle is once your buzzer can go past that 1,000, it's not going to go past the 1,000. You can always put any value. If I put 65,000, my buzzer is still not going to get to 65,000. You get the point. So I can put any duty cycle. It will get to the maximum duty cycle that I want to get to, and everybody's fine. Now I created a function. The function is called play notes. Play notes, and I am getting something inside that play notes. I'm creating something called a note string.
So I did the function, right? But just tell them since they are not writing the code, they should just see the code.
I learned you guys didn't learn anything about functions. You learn more about functions tomorrow. I created a function. To create a function, you use the def function. This def means you want to create a function. You give it a function name and you get something from it, like an argument. You get something from it, no strings. Now inside that function, I splitted my notes array. And for every notes array I get, I will play a tone. You guys learned about for loop, yes? You guys learned about for loop. Now, once my note is not S, it's going to play what is inside here. If note is not S, it's going to play what is inside here. And it's going to sleep. Else, if it is S, it's not going to play anything. Now, down here, I wrote the tones for different music. Mary Had a Little Lamb, octave, and Twinkle Twinkle Little Toes. Then inside my while loop, inside my play notes, I decided to play Twinkle Twinkle notes. If you run your code, you should hear the tone of Twinkle Twinkle Little Stars. You guys will learn more about functions tomorrow. Sorry, I cannot explain it very well since you guys don't understand it yet. I can't explain it very well like your Python teacher will explain it. But you guys will learn about functions tomorrow. You will hear Twinkle Twinkle Little Stars. Now, if I want to play Mary Had a Little Lamb, that argument that my function that I play notes function takes, I will change it to Mary Had a Little. I'll change it here. If I want to play Mary Had a Little Lamb, I will put that Mary Had a Little Lamb function there and run your code again. You should have something else. Change it, try it. Throughout this analog class, we'll be learning how to use our duty cycle and our frequencies to turn servos, to change how things sound and the likes. Do you guys have your buzzer playing something else? Do you guys have the music playing? All of you? You guys? Okay. You guys, is it working? Can you hear it? It's not. Okay, don't comment this here. Okay, no, you don't need to comment it. To start. Did you change your pin number? Did you change your pin number? Is it not working?
You're still downloading the file.
Okay. You guys have your own working, yes? You guys have your own working, yes?
All right. We still have a lot to do. We still have a lot to do, Joe.
You guys have it.
Right, so I noticed that some of you now do because see a place where there's buzzer.
Yeah, you can change your PIN number. Yeah, buzz is equals to PWM. You put your own PIN number here. If your buzzer is not working, yeah, they have their own one.
So you are not even to 0, you have changed that 0 to 0.
All right, to continue. You guys have a serve on your table, yes? All of you have a serve on your table. Something blue on top of your table. Yeah, please remove it. And take one of these attachments, just anyone. Like this, these attachments box. Just pick one and attach it to the top of your servo. It should look like this. These are the attachments should look like this on top of the servo. If you place it on top, it should look like this. Can everybody see this? The attachment should look like this on top of your servo. We are running servos because you guys are going to be assembling your robotic arm, the electric part of your robotic arm yourself. So you guys should please listen very well to this servo part. But okay, yeah. Do you have the display? It's working. Okay, that's good. Now on your servo, you can notice you have 3 pins, 3 pin outputs, 3 wires coming out. 3 wires, 1 yellow, 1 red, 1 brown. 1 yellow, 1 red, 1 brown. Everybody. Add 1 attachment to your servo. 1 attachment, just 1 of it to the servo. The yellow side is your signal pin. That yellow wire is the one you will connect to any GPIO pin. The red wire is your VCC, is your 5 volts. That is your big bus. Then the brown wire is your negative. That is your ground. That is your ground. You want to run a quick servo test to test if your servos are working. I want to run a code that will make this servo move 180 degrees to the right and then move 180 degrees back. The ground is brown. Brown is black, is ground. Your yellow is signal. This could be yellow or orange. Your yellow is signal and your red is BCC. Have you connected our servos? Have you connected our servos? Everybody. You guys are connected to servos? You guys are connected to servos? The red, yellow to any, your yellow signal pin to any GPI opening of your choice. Any GPI opening of your choice. You guys are connected yours. You've connected yours. All right. The yellow to any GPI opening of your choice. Red to VBus, exactly. Then VBus, your VBus is your 5 volts. This is VBus, should be probably on top here. So you guys connect your VBus. VBus to red, brown to ground. We try to simplify this servo code as simple as possible so that it's easy for you guys to code these things yourself tomorrow. Now, inside that zip file that I sent to you, there's something called servo.py. Servo.py. There's something called servo.py. Don't bother to open it. It's very complicated inside. This is what is inside. Servo.py. Don't bother to open it. We will just be calling some functions from there. Just extract it. Servo.py. Inside the zip file I sent to you guys. Servo. Just extract it to your location. Extract it to any location. Have you extracted it? Have you extracted it? Now, on this your files panel, go to where you extracted your servo.py. On this your files panel, this files panel here, can everybody see it? Go to where you exported your servo.py. On your files panel, on this files panel, go to the directory where you exported your servo.py. If you cannot see your files panel, go to view and click files. If you cannot see your files panel, go to view and go to files. You have seen your servo.py. Has everybody seen their servo.py? You guys have seen it. You have seen it. Yes. Now click on that servo.py, right click on that servo.py and click upload to. Right click on the servo.py and click upload to. Your Tony has to be connected, your Pico has to be connected. Make sure your Pico is connected. If your Pico is connected, it should show you this interface. It should show you this environment. Raspberry Pico under the File Explorer. It should show you this environment. Then once your Pico is connected, click upload to. Once it uploads, this servo.py shall appear under your Raspberry Pico. Has everybody done that? You guys are done. You guys are done. You guys are done. Are you done? Check. You guys are done. Chest bar. Okay, don't open it. You don't need to open it. This is where you have it, Abby. Okay. You upload. All right. Okay, your Python, make sure your Pico is connected. Connect your Pico. Do you guys have this? Please let's type the code on the screen. We created that library so that it will be easy to tell your server to go to right and left. You can see I imported time. All of you can see I imported time. I from servo, import servo. Note the two, this starts with a capital, this starts with a small. Then I created a variable called S1, and inside that variable, I called servo and pin 3. That 3 stands for pin 3. So you can change it to any GPIO pin of your choice. You can change it to any GPIO pin of your choice. Has everybody done? Has everybody typed completely? Is everyone done with typing? You guys are not done. You guys are done. You guys are done. At the back. You guys are done. Are you guys done? All right, is everybody done with typing the code? All right, we are waiting for you. We are waiting for you. Time.sleep. You can run underscore. This is what you're confused about, yes. Yeah. It's fine. Is everybody done with typing? Is everyone done with typing? Is everyone done with typing? Are we all done with our typing? Is everybody done with typing, please? If you are done with typing, run your code. And see the reaction of your servo. Run your code and see what your servo does. Is your servo rotating? Is it rotating? Is it rotating 180 degrees? Check the code. Check the code. Only turn, okay. It's not turning back to 0. Okay, check, see your sleep function. Your sleep is milliseconds, should be milliseconds. That way is not, you have to wait 200 seconds for it to turn back. Yes, that is why I use millis. No, change the other sleep too. That's correct. Yeah. All right, run your code again. Now you can see that your delay is too short. If you see that your servo is not getting to 180 degrees, increase the delay and run it again. Increase the delay and run it again. If you, your delay is at 200. This is 200 seconds. I ran milliseconds. Sleep underscore milliseconds. Check your connection. Are you on GPIO 1?
And connection is 0.
Is this?
That yellow is for GP.
This yellow is for GP. This yellow is for GP. Okay. This guy is for BBOS and this guy is for ground. Sure. Run it again. Try this out. Try this out. No, that's not correct. Okay, your GPs, that's not correct. So that's your GP is yellow. Sure. Then run it again. There's something wrong somewhere. Okay, let's switch your pins to GP3. Switch it to 3 and let me use this ground. Should not be done. 3. It's not specific. Right. Is it working? Now increase your delay. If you increase your delay, you allow your server to get to 180 degrees completely. Then increase the delay of boot, change it to 2000. Yeah, 2000 your delay. Switch your delay to 2000. And then run it again. Every 2 seconds to go. You guys have yours. Is it working?
Yeah. The PC, one of the PCs went off. The PC that was writing the code.
You guys, it's not working. I'm waiting for you guys. I'm waiting for you guys. All right. 180. Yes. The maximum degree is 180. Yes. That means it will not go. It can go 90. Yes. You can try other degrees that are not above 180. So you can run 60 degrees. You can run 90 degrees. You can run 360 degrees. You can run 360 degrees. Yep, sir. Because that's the if you try to turn your servo past 180, you see it as a mechanical stop. One, two, three, 4, 5, 6, 7. All right. So since you guys are going to be dealing with 6 servos tomorrow, I'll be sharing 1 extra servo for each group. Try to turn your two servos at different times to different degrees, and let's see how you guys can do it. Now it is important for you to note, at that point where you have S1, you have to create another variable to create pin for the second servo. To create pin for the second servo. I give you guys another servo, yes? I give you guys another servo. All right. So 2 servos. Note to mail, I'm coming. Note to mail wires. Note to mail wire. Yeah. I think there are some bad ones under the table.
Bad ones?
But they use it like that. I have some funny one. I have some funny one. Note to mail for them. Best fit. How many? 2 extra, 3 extra. This is mail to mail. This is mail to mail. This is mail to mail. This is mail to mail.
How many did they need each?
Probably give them 3. All these are mail to mail.
3, right?
Yes.
This means they don't have extra mail to mail.
No, I gave them. I don't know how many they give them initially. Just give them 3 everybody. And if you need mail to mail, they are sharing. 3 is fine. 3 should work for you. Yeah, they are bringing mail to mail for you. What is it? The red is also BCC, big boss. Yeah, how do you connect it to your breadboard and share it? You have one big boss, connect it to your breadboard and share it. Now edit your code. Let your 2 servos go to 2 different degrees at 2 different times.
You guys should be fast. Have you all connected our servers? Can you all change our code? Everybody can change their code by themselves, yes? They have to create another variable for the second server.
Yeah, that's because I printed at this point. Once it goes left, it should print on left. Once it goes from right, it should print on right. That's why it's showing at the bottom side.
Plenty, but this one is okay, let me run it again.
Okay, this is on S3. Is that S3? S3 is that servo 3 should be here. This is servo 3. I called a function and I put the pin number inside here. Okay. So the GPI opening should be on S3. Do we get it? Now try to run it again. Now that delay is too short. Since the delay is too short, it won't complete the entire cycle. So if you change your delay to probably about 1 second, you would have it run go once. Okay, so the class work is use the two servos at the same time, just one code. Use the two servos at the same time to get two different angles at two different times. Let's see. What did you get? This is too short. For 100 milliseconds is too short for a delay. Then okay, then 200. Run it. All right, everybody. Wait, let me see this. That's too short. Increase your delay. Let's see better. There are two groups that have done this. All right, okay. This is okay. You guys are running what's the degree? 45 degrees. Your degree your angle does not necessarily have to be 180. You guys can try it with different types of degrees. You can try it with different types of angles. If yours is working already.
You guys are not doing it. You guys are not doing it. All right, you guys. Are you guys done with yours? Okay, let's see. Second one is not working. All right, what is the pin for your second one? Where did you call the pin? You are not supposed to, no. You are supposed to create this while true is once. You can really have one loop in the code. So every other thing you are going to do inside that loop should be inside the loop. So you are defining your pin outside the loop. So define your loop here. Define your servo here.
Just copy this line.
Copy this line. Copy it up. Copy it up. Yeah, copy it up. No, don't delete it. You don't need to delete it yet. Oh yeah, delete the while true. Yeah, under. Delete this while true under. Yeah, run it again. I don't know why I didn't give you an error though. The second one should work. It's not moving again. This is inside the while true. Let it come up. Hold on, come on. Okay, you have your S1 to go to 0 and this guy to go to 0. The other guy is supposed to go. This other guy is supposed to go, yeah. Yeah, okay. There's something. Yes. Wait, your cable is disconnecting. Why? Your cable is disconnecting. Why? Switch your delay to probably 1000 to have faster reactions. Are you guys done? You're done with your. Are you guys done? You're done with your. It's okay. So you have to create. Okay. Now here's the second servo. You guys should use two servos. Use two servos. Turn the two servos at the same time. Control two servos at the same time, not just one servo. Two servos. Then the second servo. Are you guys done? Is it working? This you have to put a time delay between your first 180 and your second 180 so that it will have time to get to 180 degrees before it goes back to 0. So if you have like a time dot, copy it. Okay. Sorry, copy the entire thing. Copy the entire thing. Place it between your angle here. Yes. Place it between your angle here too. Yeah. Okay. Indent this other guy. Yeah, run your code. Okay, invalid. Okay. Your two servos should work.
This is working.
You can play around with the angles to see how you can see what different angles you can run. Okay, everybody has done that, yes? Everybody has played around with that, yes? Now you notice that you guys have this thing on the table. This is called a potentiometer. This is called a potentiometer of variable resistor. What is inside this guy is 2 potentiometers and 1 button. This joystick module is 2 potentiometers and 1 button. So once you use this potentiometer to control our servo, hold on, I'm coming. You come in. That's too much. Variable resistor explains itself. That one has stood in the game. Anything they want to do, they do. You guys should ignore the battery side. Connect your potentiometer. The first leg. If you have your potentiometer facing you, the first leg to your left is your VCC. That is your 5 volts. The middle pin is your signal pin. Then the last one is your ground. Just connect it. I'll show you guys how to code that. Your potentiometer facing you like this. The first leg is your VCC. The middle is your signal, and the last is your ground. The middle is to any pin, any GPIO pin. Facing you like this. The first to your left is your VCC, that's your 5 volts. The middle is your signal, the last is your ground. Has everybody connected their ports?
The other servo is not running.
You have to. Okay, you didn't run your second servo.
Yeah, connected it.
Yeah, you didn't run your second servo. Okay, so I want to run my second servo now like this. I have. Okay, let me increase the delay. I'm coming. Let me increase the delay. I run servo 1. I slept for this. Let me run servo 2 now. So if I run servo 2. That is, you created a variable here, S2, yes? So you run servo 2, you sleep again, then you run servo 1 to go back to the other angle, Abi, and then you sleep again. So servo 2. Run it. Put your potentiometer inside your breadboard. Enter your breadboard. Disconnect every previous connection, then can't connect the new one. Is this on pin 4? Confirm, is it on pin 4? If it is not on pin 4, check it very well. It is working. Sorry. Good. Ensure it's on pin 4. Is it on pin 4? Your signal. It has to be on pin 4 for it to work. Okay, this is GPL4, this is GPL3. Here's 4. That is signal. Your red is your red. What is this wire? This wire is not good. This wire is not good at all. Sorry. You have another jumper. Hold on. I should have. Okay, you have another one. You have another one. Run this. Hold on. This is your V bus. This is your V bus. You guys just bridge the stuff. No. You guys just bridge the stuff. This is ground. Not you connected. Is this servo what? You bridged you made the wrong connection. Sorry, this is your 5 volts. This is not your 5 volts. You connected it to the wrong place. Hopefully it still works. Hopefully it still works. Sorry. You can see that. You can see that. You can see that. So please be very careful of your connections next time. Your red is your VCC. That is your 5 volts, and you tap your 5 volts to that rail. So you didn't tap it to this rail. This is ground. Please be very careful next time. Your variable resistor. Has everybody connected their variable resistor? Variable resistor is the same as potentiometer. Potentiometer is the same thing as variable resistor. Variable. We are going to do maths in this code, you know. Huh? Let me see your connection. Is this your positive? This is, yeah, you still not tap your ground from anywhere. This is ground, I guess. Okay, so this is ground, and then this is positive. Okay, so you can tap from there. You can tap to. Is this correct? Let me connect it to the positive side.
One line.
This is it, no, so that they can see it very well. Open way to do tap. Facing you, your VCC is to the left. Can we see it? Facing you, please ensure you're correct. Don't bridge it, Joe. To the left, facing you, your VCC pin is to the left. V bus is 5 volts. Is VCC. V bus, VCC, 5 volts. They are the same thing. Hey, VCC. Let me see circuit. All right, this is VCC, yes, and this is ground. As long as that is correct, that is correct.
Exactly.
The secretary. Calm down. Yeah. Okay, I've shared it. Hold on. This is where the secretary is.
I've shared this one, not this one.
Okay.
Let's share the whole screen.
This guy.
Let's share this.
Okay, it's already sharing. All right, have you guys gotten yours? Have you guys gotten your connection? Yes. Tony. Let's go to our Tony. And let us remember I told you about ADC. What does ADC mean? ADC. Analog to digital conversion. Remember I told you about ADC, yes? Analog to digital conversion. Now import ADC from your machine. The reason why we are importing ADC is because we want to get values from our potentiometer. We want to get values from our potentiometer. All right, do we have this? Do we have this? Now you will notice that all of you that are connected to any GPIO pin, listen very well. Listen very well. We want to convert. Want to connect our potentiometer to an analog pin. Since we want to get values from our potentiometer, we get analog values and we convert those values to digital values. That means that we have to connect our potentiometer to an analog pin. If you look at your Pico very well, you will see some pins that have A0, A1, A2. Look under. Most of it starts from GP26. You will see after GP26, you see A0 there. Do you see A0? Do you have see A0? Now, that A0 means analog. That A stands for, that pin has the ability to handle analog signals. So you want to connect your potentiometer to any analog pin, not just any GPIO pin. Any analog pin. Analog, that A0 is analog pin 01 and pin 0. Then you can use A1, you can use A2, depending on you. So every A pin, any A pin has the ability to handle analog to digital conversion. Do we understand? Do we understand? Do you guys understand? Do you guys understand what I'm saying? You guys understand? That's very good. So pick any analog pin of your choice. Now I want to get the value of my port for you guys. Let me get this. We want to get the value of our potentiometer. We want to get the value of our potentiometer. Can we see this? Can we see this? Let's run our code. Let's run our code. On your serial monitor, you should be getting a particular set of values. No, leave the servo for now. Leave the servo for now. Focus on the potentiometer. We want to get the values for our potentiometer. The values, yeah? While true, under the while true, yes. So I am reading my pin 26. I want to read my port values. And I want to print my port value. I want to print my potentiometer value. Can we see this? Run the code. Are you getting readings? You should get a maximum of 65,000 or something. Now turn the potentiometer. Your value should either increase or reduce. Turn the potentiometer. Are your values reducing and increasing? If you connected well, your value should increase or reduce. Turn the potentiometer. Wait, let me. Are your values increasing or reducing? Let me see what you guys are. Okay, you have a syntax error somewhere. Okay. On line 4. Import servo. No, that is not it. Import I small I. Sorry, Ctrl Z. This is small I and big S. Okay, that is big S. Run it again.
There should be a column.
Okay, yes, there should be a column there. Run it again. Servo isn't defined. S1 dot servo. This is big S. Okay. Now turn your potentiometer. Your value should increase or reduce. If it is not, then you have a wrong connection somewhere. You have a wrong connection somewhere. This is VCC, yes. Facing me, VCC. This is ground. This is signal pin.
Yes.
Signal pin and it's connected to what?
ADC to 28.
ADC 28. Right. That should work. It's not working. Let me try this. I should make ADC. ADC 28. So this is it. Okay, turn it. Your values are supposed to increase. Okay, first let me run a delay here. Time underscore sleep. Sorry, time dot sleep. Sleep underscore ms c 500. All right, let's run again. Run. The values are supposed to increase. What value? Run. Something is wrong somewhere. That is not supposed to happen. So I got ports. I got a pin number. Ctrl Z. I got a pin number. I got a pin number. It should be 1. Stop. 1. Okay. Done. Exactly. The value should reduce. The value should reduce and increase. So it is the values that we get that we use to control our server now like this. Do we get it?
Yes.
Is our values changing? Is all our values changing? Yes. They are the values changing. Okay, turn your potentiometer.
Yeah, at some point, you turn it to the past.
Turn your potentiometer. No, you might want to add a delay a little bit. Add a delay to the print so that you can see the change in values. Now, add a delay after this. So. Time dot sleep, not comma. You guys have yours. Is yours working? I make it 500. That's half a second. All right, so run it again. Stop first and run. That is not stopping. Oh, yeah, run it. All right, turn it. Yeah. Turn it the other way. Yeah. All right. Everybody has their values changing, yes? Everybody has their values changing, yes? You guys have yours changing. Tell that group. Not yet. Is it changing yet? Okay. While it's doing that, add a delay here so you can see the time dots. Okay.
You guys are sending
500. For everybody that has their values changing, let's do something. Let's do something. We want to run a calculation. Remember cross multiplication. Now, we want to assign that maximum value 65535. We want to assign that value to 180 degrees. I will assign 0 to 0. Now, if you remember your calculation, you remember arithmetic. If I want to get my x, if 655 is 180 and 0 is 0, and if I input a particular value, if my boss gives me a particular value, how do I get the x of that value? Okay, I'm coming. Let me draw this notepad. Hold on. So I have 65565 to 180. Now, if I get a particular value A, let's say I get a particular value A from my potentiometer, how do I get the value for x? I will cross multiply, yes. That's going to be what? My x will be what? My x will be what? 180 times the value I get, A, yes, divided by 655. Now that is what we are going to do here. The value I got, what? Now, if I'm assigning values to my servo, the maximum value I'll get from my potentiometer is 65535. Now, if I say that 65535 is 180, and I'm getting a particular value A from my potentiometer, that value will give me a particular value, yes? Let's call it x. To get x. Now, if I want to get x, how do I get my x? I'll cross multiply. I'll cross multiply. And if I cross multiply, I'll have my x to be what? To be equal to what? 180 times the A value I get from my port, divided by 65535. Now that arithmetic, we want to write this in code. The value I get from my port is what? Port value, yes? The value I want to get, the angle value I want to get is what? 180 times the value I get from my port divided by what? 65535. Do you understand the coding here? This star is your multiplication. They taught you yesterday. This is called flood division. They taught you yesterday. So if I multiply my value and I divide it by what? 65535, I should get what? The angle value. Now I am going to put that angle value inside the angle function. Remember the last time you are calling S1.angle 180, S1.angle 0. But now I don't want that. I want to put the value I get for here. I want to put it inside my servo. Now let's run that. Do we understand? Does everybody understand? Should I come again? Should I come again? Potential that I carry. Like exactly 7, like 7 you get. Does everybody understand the arithmetic you did here? You understand the arithmetic? No, the A is the value we are going to get from our servo. We don't know the value we will get from our servo per turn in years. So we are just assuming it is there. That is my port value. So my A is my port value. The value I'm getting from my port, that is the value they are generating here. So the angle that we assigned 6.5, maximum value we are getting is what, 655, yes? That's from the port. Now, what is there every time we get 655? At some point, we get another value. We are calling it port value. Yes. Now, to convert that port value to angle, you know this is 180 degrees. Yes. This guy times this guy is what? 65535x equals to what? 180 port value. Now, to get my x, that angle that I want to get for that port value will be what? 180 port value times divided by what? 65535. That is what I did on that calculation. The scaled value, that is the angle x, is 180 times the port value I'm going to get divided by 65535. All right, have you done that? Have you done yours? If you have done yours, run the code. Now, if your code is running, turn your servo. Which servo is connected? If you turn your servo, it should move. Is it on pin 3? Is it on pin 3? Yeah, change that guy. And so you change your servo pin, please. It's not on. The value is this is what? That's 26. Yeah, that's 26. That's correct. This is signal. Signal goes to 2. Signal goes to 2. Now goes to ground. Okay, one of the servos are not working. I think so. Yeah, this guy. Sorry, I'm going to put this guy. This is what? This is ground. But hold on. What is this connected to?
It's ground now. It's ground.
Okay, this is ground. That is ground. That is brown. This is your G, this is your GPIO pin. That is yellow, and this is middle. Yeah, that is big. All right, run it again. All right. We're supposed to get change in value. That is servo 2. No, this is not. Okay, this is ground. Yes. This is signal. This is wrong. This guy is changing. This guy is also changing.
Wait. This is a mistake. It's not on the same line. It's not on the same line.
So the rate of what you change it to is what is If you want a faster response, remove the delay that used to print the value. Remove the delay that used to print. And run it again. So that way you'll have better response as you are turning. If you want a better response from your potentiometer, remove that delay that is here as the print value. Remove that delay. So that way, as you are turning your port, it should be responding immediately.
Yes.
Are you ready?
Yes.
Your map.
Yeah.
That's it.
Watch.
Stop playing. Stop playing.
Second. Now, for all of you that have done your own, connect the second servo. Let the one potentiometer control the two servos at the same time. Let your potential. Good. Let your potentiometer control the two servos at the same time. Now, it is important for you to note, you don't have to change your code. You don't have to change your code to control the two servos at the same time. Eh? Use one potentiometer to control two servos. Is it not working?
No, we are doing it.
Did your work?
Yes, the first one was.
Use one potentiometer to control two servos. You can change your code if you want to, but I'm just saying you don't have to. You don't have to. Fit. 3 is now 3 are supposed to finish, have you?
What is that?
3 12.
Let them.
No, I want to do the external power supply, and that's the last one. Yeah.
But make sure you want
Yeah, let them do this. You need wait to know. Okay, I'm coming. This is one. This is another one. Did you guys get it? All right. There's a group that has done their own. They have done your own. Let me see that. That is good. That is very good. You guys have done your, you've done yours. Hold on to every group that has done their own.
I'm looking for you. Is it something like this?
Yes.
Is it what we should achieve?
That's what you're supposed to achieve with the two servos. Achieve it with two servos, with the two servos. If you want your response to be faster, you can remove the delay that is here. Yeah. So that way, as you are turning it, run it. Run it. Is something is wrong. Select the people again.
Yeah, selected it.
Select it again. Now run it again. Something is wrong. Select it again. All right, run it. All right, turn it. So it will be more smoother as you are turning it. As you are turning it, it will be careful so that it's supposed to be. It has worked before, I think.
That's what before. So I don't know.
Try and key in those wires that you drop. So the potential with a key in as well.
All right, we run it. We run it. Let's stop first. I can't get it. It's not going to run. Okay, go back here. I have to be seen. The Pico stuff has to come up. Something has to show at this point. The Pico file explorer has to come up. Yeah. Now run it again. All right. So turn. So now run for the second run. One button. No, you can. There is something you press. You can do. So it's one potentiometer for up and down, another potentiometer for the two sides. Then one button. All right. Has everybody done their own? It's not working. Hold on. Sabo 10. Run it, turn it. Check your connection. Check the connection.
This other Sabo works, but it's just vibrating. You understand?
Oh yeah.
This one did not work at all.
Is this ground or Vigos?
This is the ground. So the ground. Then
This is your signal thing. That is pin 10. Yeah, it's on.
No. Okay, signal is to this side.
Yeah. Okay, first change this. Okay, hold on. And this, and then last one. That is positive.
Yeah.
Hold on. Choose ash. Positive. That's correct. All right. Let's run this guy. So if you reduce the delay, if you remove the delay, you'll have more smoother operations than. So it is to meet what you are turning. Okay.
And just like we are doing.
So you're not limiting. You're not. Now run. You run it. This servo is also working. Try it. Run it. Allow it to control the two servos. That one potential has to control the two servos. You guys got your own. Your own is working. That's very good. All right, since you're all done, you notice that you have a power back module on your table, yes, connected to a battery. This is going to be your friend tomorrow. The reason is because we are controlling 6 servos, and you cannot tap that amount of current from your Pico. So we are going to be connecting it to an external power source. You are controlling 6 servos tomorrow. Now, there is something like this on your table too. There's something like this on your table too, Abi. Somebody will bring black tape to all of you, small black tape to all of you. You will connect red to the red side, and you connect black to the black side. You will cut the, yeah, you cut the wire, yes. Disconnect before you do anything, no. Red to red, black to black, or black to white. Connect any jumper wire, but just make sure that your red for the cable is your positive, and so you have to be very careful when you are connecting. The red on your cable is your positive. If you don't have red jumper wire, connect any jumper wire, but note what your positive is. Note what your positive is. Is your red, so just know what your positive is. Yeah. Yeah, but don't worry. Black the bills, but don't know. When they? No, you can cut the wire. They will bring black tape for you guys. You can cut the wire, like cut the wire and yeah. You can cut the wire and yeah. Yeah, they are bringing black tapes to you. Okay. I'm sorry, please, let's hurry up. You guys still have to print for tomorrow. You have 3D class for tomorrow. Yeah, you learn how to print from the machine. Okay, it's what power bank module. Okay, you guys didn't listen to the instruction of the power bank module. There is this a cable came with. There should be a cable, USB cable that I cut. Have we all done that? Have you guys done yours? All right. Disconnect everything on your breadboard, please. Disconnect everything on your breadboard. No, okay, wait. Disconnect everything on the power rails of your breadboard. The power rails, the top and the bottom. Don't put anything here. Don't put anything in your power rails. Disconnect everything from your power rails. That is the top and bottom, please. Disconnect everything. Have we all done that? Now, plug. Yeah. Disconnect everything from that power rail. Disconnect everything from the power rail. If you don't know what your power rails are, these are your power rails. Look up. If you don't know what your power rails are, these are your power rails. The ones on the top and on the bottom. All right, if you have done that, connect the USB parts to the power bank module. Make sure those two wires that are coming out do not touch each other. If you touch, you say smoke. If you touch, you say smoke. If you join it together, you are joining positive and negative together. Actually, technically, there's no negative or positive on power rails, but they just put it there just to... Oh, the potential meter, no, to your left, facing you, to your left is your positive. All right, together. All right, if you are connected to your power bank module, connect one end. Connect your positive to the positive of your power rail and your negative to the negative of your power rail. Please note what your positive and negative is. The red wire of your cable is your positive. The red wire of your cable is your positive. The red wire of your cable is your positive. I don't want them to connect the people. I want them to connect maybe buzzer or something. When they connect buzzer. I don't want them to connect the people. I want them to connect buzzer. If you don't on, yeah, so that they will be very sure what their positive and negative is before tomorrow. Okay. So if you give them, this is where I want to stop.
They have a buzzer already.
That's passive buzzer.
Okay.
So that they can get. Show your positive and negative is correct. You are doing that so that you guys will not breach the Pico, the controller. That's why we are doing that.
Ensure that you are talking with the other one and not in the same way. Not in the same way. Some people.
Where's your positive and negative?
These are positive.
That's not going to work. It's not connected now. You connected these two wires together. You connected those two wires together. You are supposed to. This is not connected. Yes. This is where it's not connected. So this is what. This is positive. Yes. To the positive side. Sorry, I'm coming. This is the positive side. Okay. Is this positive? Is this correct?
Yes.
Then the negative.
It is too close.
Where's the negative? The negative to this is correct here too.
Yeah, move the point.
So you get what I'm doing? You get what I did? You get what I did? This is why I'm giving this buzzer so that you will not breach this thing. Because this board is very fragile. If it goes near. So you know what your positive is, and you know what your negative is. Do you have it sounding? Do you guys have it sounding? All right, thank you very much. We'll be ending the class here today. We'll be ending the class here today so that you can run your Fusion 360 class. We will continue from there tomorrow. Remove your buzzer. They connected it to the potentiometer, so you can turn and reduce it. So you can send somebody from your group to return the components, please.
So while you're sitting down, I need you to launch your Fusion 360. It's been 2 days with Fusion 360, and today we should continue what we started, right? So in the next 30 minutes to 45 minutes, we're going to be working on your Fusion, on your computer-aided design class. So please, can we appreciate Mr. David again for the just concluded Sqicict session. So I'm waiting for you to get ready, to get set as we continue. Launch your Fusion 360. We should be doing some 3D printing today. At times it does. So in case, I would recommend that you go online before you launch your Fusion 360. Go online before you launch your Fusion 360. Rakim. Rakim. Your PC, please. Mine is having issues. All right, so I want you to open the design that you were working on the last time. I hope most of you were able to save it. So open the design of the robot base we were working on the last time. The base of the robotic arm we were designing the last time. I need you to open it now. Do you have the design up? You started the design now, have you? All right.
gripper link, right? Can you see me? Zoom. Yeah, I'm working with that. Hello, are we together? So you remember that I said inside your bodies folder, you can toggle the visibility of an object, right? So just go inside your bodies folder and toggle the visibility of the base so that you're only seeing the gripper link. Have we done that? So toggle the base off, the visibility of the base, toggle it off. All right. So after you've done that, now I told you we are done with design, right? And I said Fusion can handle the entire pipeline of your design process, starting from the modeling to the simulation to the manufacturing process. Please, your noise seems to be distracting me. If you can maintain quietness, I would like that. So you come over to this side where you say design. So what we've been doing so far is that we've been designing, okay? We've been doing 3D modeling, we've just been designing. Now we want to go a step further to manufacturing. So we need to change what we call our workspace. So if you click on this place where you have the design, it's going to show you different workspaces that you have in Fusion 360. Are you following me? So these are, we have like, how many workspaces are there? Can we count them? So we have 7 different workspaces that we can work from. And now we're interested in the aspect of manufacture. So click on manufacture now. So don't remember, we are working towards printing this particular part. So click on manufacture. Are we all in the manufacturing environment now? All right. Now, the first thing we need to do is to set up our, hello. The first thing we need to do is to tell Fusion what kind of manufacturing process we are going through. And now, can you look at this tab? Can you see we have milling? Can we see milling there? Can you see milling? Can you see the tab where you have milling? So you have milling, you have turning, you have additive, etc., etc. So these are different manufacturing processes that Fusion supports. For our purpose now, we are interested in what we call additive manufacturing. So 3D printing is one of the processes that fall under additive manufacturing. So just click on additive. Have we clicked on additive? Can we move forward? All right. So come to your setup and say new setup. Under your setup panel, click on new setup. So you're going to have a dialog. And in that dialog, that's where we configure our machine and some other things. So can you see a input that says machine? All right, so click on that select button so that we can select the type of 3D printer that we want to use. And then you're going to have a bigger dialog pop up. So there are different 3D printing technologies. There are a lot of additive manufacturing processes. So the particular one we're using now is called fuse deposition method. Can we say fuse deposition method? It's called FDM. All right. So when you hear the word FDM, it stands for fuse deposition method. So this thing that is called FDM is also called FFF. All right. FFF stands for fuse filament fabrication. Can we see this screen? All right, let me get it bigger. Can the camera see this? Can see this? All right.
So FFF and FDM stands for the same thing, okay? So can someone explain to me why is this called fused filament fabrication? You said? Yeah, so that's because he's making use of a filament. Can we clap for him? Clap for him, all right? All right, so this fabrication method makes use of a filament. What does it do to the filament? It melts the filament, right? So that means we are fusing a particular filament to fabricate something. So that's why it's called fused filament fabrication. So that is the kind of machine we have here, okay, that we want to use for our 3D printing. So under technologies, you want to filter. So just click on FFF. So that is going to show you only machines that that support FFF. All right, so next thing.
What it means for the planet world, so we need the zoom. I guess it's the
This guy is not going to project right now, so there's really nothing I want to do. He's having issues with HDMI projection.
Now, how many of us can see a list under this page? After you click on FFF, you can see a list. All right, so my Fusion is having issues. You should actually see a list of machines. So what I need you to do is, how many of us can see that list? Please raise up your hand so we can see a list on that page. All right, that's very good. So I need you to scroll until you find a machine called Creality and 5+. Look for a machine named Creality. Creality and 5+. That's the machine we are using. Creality. You should find a machine called Creality and 5+. How many of you have seen that? All right, so click on that machine.
How much your PC does? Your PC. So I'll be using your PC. Do you mind? Doesn't have HDMI. All right, let me see someone else on my HDMI. Please let me see the PC. This guy is not on the internet. He's not refreshing well. HDMI.
Creality and 5+. Creality and 5+. So just click on Creality and 5+ and wait for the next instruction. Nothing. This has not refreshed.
all of them are the same.
Some machines are not same. It's going to turn it off.
So please give me a minute while I resolve the technical issues we're having here.
This is going against time. So most likely the rest of this will not be streamed, but it's not nice if we don't do this again. That's all. Once time will be fine. It's not showing the machines. No, I just need a connection between this and this. Let me support it. This phone, this phone. USB cable. The USB cable, I'll be using internet over the cable. Yeah, it's for okay. It's for him too.
You have issues connecting.
Yeah, exactly. So with this, I should have internet over cable.
Yeah.
Yeah. Okay. In that same dialogue where it asks you, do you want to do file transfer? Have you seen that?
Actually, that one I didn't do that. This course is just started. Let me look for that.
Look for my cable, bring my cable on the desk. My cable on side. So I'll use my internet. This thing was working via HDMI yesterday, and then decided to use it.
Which issue are you having?
The second piece is Fusion is not refreshing, so it's not showing the machines I'm meant to use.
Is that one?
Yeah. All right, so I'm going to be giving you instructions on what to do next while I'm waiting for this to launch. So for everyone who has seen the Creality Tender 5 Plus machine, I need you to, okay. All right, so you see a select button under the dialog page. So click on select. Can you see a select on the bottom right? All right, so click on select. Ender 5. You should look for Ender 5. All right. All right, so the next thing you see a print settings dialog, right? Can you see a print settings button? Can you see a print settings button? So click on that print settings button. Click on the print settings button. Machines are not refreshing well. Are we all in print settings now? Can you see a print settings button under the dialog on the right? Print settings, yeah, click on that button. How many people are in print settings already? Now you're going to see a dialog. You're going to see different types of materials. Okay. Can you see ABS? All right, you can see ABS. All right, so you scroll down until you see PLA. PLA, scroll down until you see PLA. All right, so there's a PLA that has bolding too. All right, so click on that one that has bolding too. Your machine has gone offline. All right, so click on select. So what we are doing here, we've done two things so far. Number one, we've tested Fusion, the machine we want to use. And number two, we just inform Fusion of the material that we want to use to print. Is that okay? All right, so we've not done anything out of the box. PLA boarding tube, that is what you should choose. PLA boarding tube. So click on select once that is done. And then you wait for me to show you the rest of the steps. So we're almost done. For model, just hold on. Hold on. So have you seen boarding tube? All right, so make sure your machine has gone back online, and then you close that window and reopen it again. All right, so what we've done so far is the first step, we change our workspace to the manufacturer workspace. What's the next thing? Yeah, we go to our setup. So we say we want to make a new setup. And then I told you, if you expand this a little bit further, you want to look for this bodies folder. In case you are still seeing this big one, I've asked you to turn it off before. But in case you are still seeing it, you see this manufacturing models, expand that folder, expand this manufacturing model one, expand this, expand the bodies folder, and turn off one of the bodies so that you can see only the gripper. So next thing is you want to change it, you want to select the machine type. So on the dialog that shows from your setup, click on select. Now it's going to bring up a page for you where you can select the machine you want to use. So while you are doing all of these things, you want to make sure you are online, okay? So under Fusion 360 library, if you scroll down, you see Creality and 5+. So you were expected to see something like this, all right? If you are not seeing that, that means your machine is not online, your internet is not strong or some other thing. So click on that machine, press select. So if you look at that machine, it looks exactly like this. Can you see this image? So we are just trying to tell Fusion what machine we're trying to use to print. All right, so if you're going to see a very big, window, so you can zoom in and zoom out, all right? You still remember to zoom in and zoom out. In case the box you are seeing is very big like this, like my own, so just come to your zoom button under here and then zoom out a bit. Is that okay? So zoom out a bit so that you can see a smaller machine. So once you have done with that, I said go to print settings. So this is where print settings is. Click on the print settings. And now, under Fusion 360 library again, this is what you are going to see. If you scroll down, you're going to find PLA. So you want to choose the one that says PLA in a boarding tube. So the PLA direct drive is a little bit different. Now the question is, what is the boarding tube? Now if you look to my right here, can you see a white pipe? A white tube. So that tube is called the boarding tube, okay? Some machines use a different technology for driving the filaments into the extruder. The extruder is the one that melts the filaments. Or the hot end, yeah, the hot end on that guy is the one that melts the filament. So the filament passes through the boarding tube into the hot end, okay? So since our machine is using a boarding tube, we are going to choose boarding tube. So just click on boarding tube. And then you say select PVA. Oh, sorry, that was a mistake. So I should be selecting PLA instead. So scrolling down, PLA boarding tube, select. All right, so if we go down the rest of this dialog, it says operation type, it's additive, arrangement, manufacturing model. Hope you're following. So this place that says model, click on select, and then just click on this. If you zoom in a little bit, click on this link, all right? Come down to the model on your dialog. The place here that says model, all right? Just click on this select button and come and click on the link. Is that okay? So this should change to body something or the gripper link. The name should change. Are we doing that? Have we done that? So that's how Fusion knows what you want to print, exactly what you want to print. So the moment you do that, you can press OK. But let me try that again for people that didn't see. So you can see it's just select now. There's no name there. So that means it has not identified anybody that wants to print. So click on that. Click on this gripper link. That is what we want to print now, okay? Click on it. The name here should change to whatever the name of this body is. So the moment you've done all of that, you can click on OK. All right, so in case you see a window like this that pops up, if you see this window pop up after you click OK, just press OK. What this guy is trying to do is he's trying to help you to arrange your parts automatically on the print bed, okay? So just press OK and see what it's going to do. So you didn't do a good job. So this is actually what we need to do. We need to change the position of this thing. Oh, all right, you did a good job. It should center it for you. How many of you have it centered after clicking on OK? Is it centered now? How many of us have it not centered? It's not centered. It's not centered. It's centered, but it's standing vertically. All right. So we need to change that. So come to this. You can see a panel called position. Can you see a panel called position? So click on this move component. So in case your own is so you're going to be seeing highlights of this, but no problem. In case your own is standing vertical, you want to click on this one of these arrows, and then you want to rotate it by 90 degrees. All right, just rotate it by 90 degrees, and then you press OK.
So, but mine is okay before, so I'm going to cancel that. If yours is not okay, just rotate this by 90 degrees. Once you do that, you can see mine is standing vertically now. You can see this gripper is standing vertical. So I should actually just leave it as 0 and press OK. So you should have it standing on the floor, on the plate of the print bed now. If yours is still standing vertically, let me see your hands. It's still standing vertically. It is floating. Okay, we'll fix that. Yours is standing vertically. Can I see your hand? All right, so click on Move Components. So you want to move this. And now it's standing vertically. Just rotate this by 90 degrees. So just enter 90 over here, press Enter. And now you can see it lying here. But I still don't like the way it is, all right? I need to turn it like this. So click on Move again. And then you will turn it 90 degrees in this direction. Now you can see it's better. It's floating, so we'll deal with the floating issue in a second. We'll deal with the floating issue now. So how many of you have the part floating on the bed? It's not sitting on the bed. It's floating. All right, so this is what we do to correct that. So if your part is floating, can you see this icon here? This icon that says place parts on platform. Can you see that? So click on that. And then you've selected one thing, press OK. Has it touched the ground? Good. Click on place under the position panel. Click on place parts on platform. All right. You're going to have a dialog. So just say OK. It's going to have for the clearance you want. The clearance should be 0. So just say OK. So there's a 90% chance it's going to be touching the print bed. Now, is it touching the print bed? All right. Good. Is it touching the print bed? Is it touching the print bed already? All right. So we're almost done. So after you've done that, we'll talk about supports later, okay? The part we are trying to print now doesn't use what we call supports, but when we get to a part that requires support, I'm going to discuss that with you. So next thing is just come over here that says generate. Can you see a part in the actions panel? On the actions panel, click on generate. So if it brings this dialog, just say okay. All right, so how many of us have clicked on the generate button? All right, so just hold on. So in case you see this dialog, just press yes. Click on this generate button. If he asks you any question like this, just say yes. It says, do I want to generate this operation anyway? Just say yes. Do you have that done already? So the way you know that is done is you are going to have a green check, right, under everything on your setup folder, Okay, under everything on your setup folder, you're going to have a green check. Okay, we've set the machine, that's green. We've set the material. The material is PLA, all right? PLA stands for polylactic acid. It's a type of plastic material. And then we've arranged, that is checked, and now we've generated our two parts. Now, can we read this? What's this called? Additive what? Additive two parts. How many of us have generated the two parts? How many of us are still having issues with generating two parts? Yours have not generated? All right, so I'm going to come around. All right. All right, so this is not placed on the bed yet. So what you want to do is come here, place part on the platform, and you say okay. Now go back and generate. It's generated. All right, good. Not yet. All right. So you can see it's not on the platform yet. It's still floating. Yeah, if you do it. So for those of you that are having issues, just try and do a 3D orbit. It's most likely that the part is still floating. All right, so I'm coming. So if you look at this, it's laying on the side. So you want to turn it around. So come to move. And then you want to rotate it in this direction, so by 90 degrees. Press OK. Right, so now we said it's floating. How do we deal with floating? Place parts on platform. Good. So try and zoom out. Click on place parts on platform. Yeah. All right. So if you look at this too, it's floating, right? You know how to do 3D of it. All right. Yeah. Good. So first thing, this is lying on its side instead of its back, right? So you want to rotate it. Use this move tool to do rotation. So click on this, and now I'm going to rotate this around by 90 degrees. All right, punch 90 on your keyboard. Press enter. Good. I will look at it from this side. This is the bottom. Why is your machine is oriented in the red way? There's no problem. So if you notice now, this is still floating up, right? And I said if you need to place the part on the platform, use this. All right, so click on place part on platform. All right, say okay now. All right, it's touching. So now go and generate here. It will float up by itself. Oh my goodness. Was this what happened before? Yeah. All right. All right, I'm coming. Yes, is having a peculiar issue. So this is what I'm going to do. I'll go back to your design. And you need to remind me to come and change this data. So I'm going to remove. Oh, sorry. I'm going to remove the base temporarily. Where's the remove button? Remove. So go back to your design workspace. All right. Then you go back to manufacturing again. So place this part on the platform. Generate. Yeah. Good. So are you back to your design workspace? All right. So the issue is because you probably didn't position it well when you're designing it. So what I need to do now is I'm going to grab these other two bodies. I'm going to hide them, remove them temporarily. So what you need to do is you'll need to call me after now to come and fix this for you. All right. So go back to your manufacturing workspace. All right, and now go back here. My goodness. Right. You want to take the screen. You want to place the parts on the platform again.
I'll click on generate again. Yeah. So it's good now. All right. Who else is having issues with generating the code? Oh my goodness. All right. At least someone in your group has done it, right? Because of time, I want us to go as fast as possible. You said?
When I position it and generate, it moves back up.
It moves back up. Is anyone in your group getting it? All right. You need to call me back after now to come and fix this. There's an issue with the way you designed it, and that's what's giving us this. All right. So place parts on the platform again. Generate again. All right. You can generate again. Then generate. So this is going to work. All right, so I'm sure most of us have. Is anybody in this group, has anybody gotten it to work? So it's due to the way this was designed, okay? So probably some of you didn't follow the instructions I gave yesterday or Monday. So go back to your design workspace. I'm going to remove the particular body that's affecting it. All right, so that's the body affecting it. I need you to be doing the same thing. So when you're done, go back to manufacture and then place the parts on the platform again. Generate again. It's going to give you an error first. Click on generate again, and then you say yes. So now you don't have any issue. All right. All right, so after you finish generating, are we together? So after you finish generating, if you look down here, it says what? Additive two parts. All right. So when we say two parts, what does that mean? You want tool and parts. What does that mean? Tool parts. Where you can find your tools. Okay. How the machine will move. Okay. Who else has an idea? The word tool parts. Oh yeah, no. This is nursery 3 students classroom. If I say Johnson's part, what does that mean? The track that Johnson followed, right? So if I said two parts, what does that mean? Yeah, it means the path that the tool will follow. All right, so this guy is a CNC equipment, all right? It's controlled by a computer code. And it has a tool that needs to be, that has a path that it needs to follow, okay? So basically the word two parts means instructions for how the tool on a machine should move, okay? So Fusion is trying to generate the instructions for the tool on a 3D machine on how it should move. So once you've done all of that, at this point, we have our tool parts already. So at this point, Fusion has generated instructions for our machine already, but we just need to get that instruction from Fusion, okay?
So that instruction for the machine is called a G code. Can we say G code? Say G code again. You need to remember that word if they wake you up from your sleep. G code. So the G code is the instruction for the machine on how the machine should work. So now we need to get our G code from Fusion 360. Once we get our G code, we pass that G code to the 3D printer, and the 3D printer executes the tool part inside the G code. Is that clear? All right, so how do I get that G code? Can you see G1, G2? So that button that's the icon of G1, G2 is called post-process. So now we want to post-process our design so that our machine can follow the tool path in the G code. So just click on that button once. All right, so you can see the different inputs we have here. It says our machine is reality and 5 plus, post-process, etc. The name number. The only thing that we're interested in changing here is the file name. Okay, so just change that file name, change it to the gripper link. The file name only. Change the file name to gripper link. File name only. All right, so once you're done changing the file name, click on post. Click on post. Now, can you see the output folder? I need you to take note of the output folder. So this is going to be saving the file in my downloads folder. So you want to make sure you take note of where it's going to be saving your own file. Are you getting that? So make sure you note where it's going to save the file. So click on post, and then it's going to save a G-code file wherever your output folder is. Should we do that again? Have we gotten that? All right, so go to under your actions panel, click on post-process. Click on post-process. And I said the only thing you want to change is the file name, right? So currently the file name is 1001. That doesn't make sense to us as humans. So change it to gripper link. And I said you should take note of the output folder. Where is Fusion going to be saving the file? For me, it's going to be saving it in my downloads folder. Is it saving it in the downloads folder for everybody? Where is it saving your own? You said? Oh, NC program. Okay, so we can change that position. So just hold on. Click on this. Can you see this folder icon? The one on the farthest right. So click on that to select where you want it to save it. So just click on your downloads folder or your desktop or anywhere you like. So for me, I'm going to put it on let's put it on my desktop. My desktop is very full. Anyways, I'm going to still leave it on my downloads. So select where you want it to save it and press select folder. Have we done that? Have you changed the output folder? All right, so once you've changed the output folder, click on post. All right, so you should see a message that says the CNC code has been successfully generated or posted. Are we good to go? So if you go to your file explorer now, I'm going to open my own file explorer. Go to your downloads folder. Go to your downloads folder again. And now you should see. You said? You're lost. I'm going to come back to get you. You should see the gripper.g code. You should see that file name, the gripper link. How many of us can see that already? All right. So at that point, we are ready to send the toolpath to our machine to start printing whatsoever it is that we've designed. So how many of us are still lost? Hey, our response. How many of us are still lost? All right. So apart from this group, say you're lost. All right. So you've changed the output folder to your downloads folder. All right. Now you need to post it. The problem is that the resolution of your screen is very, very small. You can't see the post button, but it's somewhere underneath here. So just press enter once.
So if you go to your File Explorer now and go to your downloads, you should see the gripper link.g code. So that is the file we are interested in. Upcoming? Nothing is there. Did you change it? You didn't select Creality and 5 plus. Yeah, it should be plus. So once you've selected there is not Creality and 5 plus. But anyways, it's the same process. You just need to change what machine you have selected. So just go and click on post now. Continue.
It's showing valid error.
Right, let me see what's going on here. Creality and 5 plus. Post. Okay, has your machine been online throughout?
Yes.
Okay, let's try post again. Invalid post processor configuration. Click on generate again. All right. So the setup, continue setup, cancel that. Everybody to this is here. Everything seems to be fine from here. Okay, so I'm going to come back to figure out why it's doing that most of the time. But it's just working. All right, good. All right, everybody. So the last time I was telling you that the G code is the two part for the machine, right? And now we have the G code file already. So what we need to do is to find a way to get that G code on the machine. Are you getting that? So I need someone that didn't have an error while they were doing their own. I'm going to come and copy one of your G codes. Hope you selected Ender 5 plus. All right. You didn't select Ender 5 plus, it's going to be giving us issues on the machine. So plug in your USB cable. All right, so send that gripper G code to the USB flash drive. Yeah, send, right click and send it to the folder. Can you pass it closer? All right, good. All right, so what I have here is just a simple card reader, okay, with a memory card inside. I'm going to be putting the G code on this flash drive. So this could be having any one of you, but I can only send one at a time. So I'm getting his own G code, and we're going to be running his G code on the machine. So plugging this in again. I'm going to come and paste it here. What OS is this? Windows 11. Right, flash. So what every one of us have at this point is actually the instruction that you can pass to your printer
So I'm going to be putting this particular G code on the printer, and I will have one group come around at a time, one at a time. Is that okay? So let me start with you since you're closer. So come around now. Yeah. Please hurry up, hurry up, hurry up. All right, so you see there's nothing being printed right now. Yeah. And I told you there's a G code. All of you have the G code right now. So now we just need to go and say we're interested in printing that particular G code. And that G code is called Gripper link. Okay. I'm going to select that. And I'm going to say start printing. So once you do that, we wait for this guy to pick that up. So, but I want another group to come and say that, the next group. So once it starts printing, you come back and you come and see the printing progress.
This property.
All right. Okay, so you add a gripper link.g code. Okay, so we've copied that G code to a flash drive. It's right here. So I just need to say print and select that G code called gripper link. So the moment I select that, I can say print. So this is going to be different for different machines, but it's still the same interface. You just need to go and select whatever the file is and say print, and then you start getting your print job done. Yeah, there's a flash drive. This is the flash drive I used to collect that from them. So it could have been it's the same as your own G code as well. So you add the G code file, right? Yes. And now we've copied that G code on this SD card. So we just need to come to the machine and say we're interested in printing which of the G codes gripper link. All right. So I just need to select that gripper link and say print. So the machine is going to start prepping itself, and I'm going to explain to you what it's doing while it's prepping once the other group. So this is what it's doing. It needs to, we said it's fused filament fabrication. It needs to melt a filament. So that means it needs to heat up this guy that's melting to the filament. And that is what it's doing. So you can see it says the nozzle temperature should go to 215 degrees Celsius. It's currently at what? 148 degrees Celsius. You can see it's increasing over time. And the hot bed should go to 60 degrees Celsius. This is the hot bed. It's currently at 42 degrees Celsius. So once that is done, it's going to start printing the object. So once it starts printing, you come and see the printing progress. All right, so let's hurry up, let's hurry up. We don't have the luxury of time. All right, so you had a gripper link.g code, right? So what we've done is we've copied that file on this card reader, on this SD card. So just when you come to the machine, it can be this type, it can be any other type. The interface can look just a little bit different, but still a similar concept. So I need to say print, and I need to select the G code I want to print right now. So I'm going to say gripper code, and I say print. All right. So now we said this is fused filament fabrication, right? So that means you need to make a particular filament. Now what it's trying to do now is trying to heat up the nozzle, the hot end that does the melting. Now if you look at the screen, it says it's going to 215 degrees Celsius for the nozzle. What's the current temperature? 141. So it's still heating up, right? It takes time for it to heat up. And now it needs to take the hot bed. This is called the hot bed. That was where you are placing the model on. What's the current temperature of the hot bed? It needs to go where? 60 degrees Celsius. So once it gets to that temperature, it's going to start printing. So once it starts printing, you just come back and come and see the progress of the print job. All right, next group. So you had the gripper link G code, right?
Now the G code is not for you again, it's for the machine, and we've copied that on the SD card. All right. So what you need to do is you just need to come to the machine and say you want to print. Okay. Some other machines can have a different interface, but this one you can see the print is very simple. It's a very simple interface. I need to print. What am I printing? Gripper link. And then I say print. So now we say this is fused filament fabrication. So that means this is the filament at the black. What's the color of that filament? Black. So that means when it's printing, it's going to be printing a black object for us. Okay. So it needs to melt that filament, right? Before the plastic melts, it needs to get like 200 to 15 degrees Celsius. So if you look at this screen now, it says the nozzle temperature is what? 196, and it needs to get to 215 degrees Celsius. So it's still heating up gradually. The moment it gets to 215 degrees Celsius, it's going to start printing. But it's not going to heat up only the nozzle, it's going to also heat up what we call the hot bed. This is where you place the object, where you are doing place on platform, etc. So what's the current temperature of the hot bed? The hot bed, 59 is going where? It's going to 60 degrees Celsius. So once it gets to 60 degrees Celsius, it's going to start printing. So you just need to come back and see what the progress of the printing is. Is that okay? Yeah, I won't let it start. I'll let the other guys come and see. All right. All right, so you had a gripper link G code, right? That's the G code you generated. Some of you have not gotten it. We'll sort that out. So, but normally what you get is the gripper link G code. Now you've copied that on this SD card. So you just need to bring that SD card on the machine. So what do you want to do? We want to print, right? So if you're using a different machine, the interface can look a little bit different, but still the same idea. So this one has a very simple interface. So I just need to click on what? Print. And then I select the file I want to print. What's that file name? Gripper link. So I select gripper link. Now I say print. So now it's preparing to print that part. What is it trying to do? This is fused filament what? Fused filament, what I call the FFF. Fused filament fabrication, right? So that means there's a filament. This is the filament at the back over there. What's the color of that filament? Yeah, so you can have that filament form in different colors. You can have white, you can have blue, you can have yellow. In case your favorite color is yellow, etc., etc. So this is black, and that means the plastic that is going to be melting is going to be a black color. So it needs to take this filament, right? Drag it in gradually and melt it. So this is the guy that's responsible for melting the filament. I told you this is the bonding what? The bonding tube. So the filament is coming from the back through the extruder here. Is the guy pulling it. There's a guy over there. Can you see something that looks like a wheel? That's the guy pulling the filament from the filament spool, passing it through the bonding tube into this hot end. So this hot end needs to heat up to a point that can melt that plastic. So if you look at this place, I have two temperatures. I have the nozzle temperature and the hot bed temperature. What's the current temperature of the nozzle temperature of the nozzle? 203. Where is it going? It's going to 215 degrees Celsius. So that's what it's doing gradually now. And you can see it increasing. It's now 208, 209, etc., etc. So it's not only the nozzle that needs to be heated up, it also needs to heat up this hot bed, right? So that the object can stick on the bed. So if you look at the hot bed, what's the current temperature of the hot bed? 60. Where is it going? 60 degrees Celsius. So once the temperature level is set, it's going to start printing. So you just need to come back and see what the progress of your print job is. Is that okay? So 3D printing is as simple as that, okay? But there are more things I'm going to expose you to, or I'm going to expose you to in the next couple of days. So let's go and wait for the job. Yeah, so it's getting ready to print now. It's about to start printing.
Yes.
Is this camera projecting on Zoom? Yes, I'm going to be sharing this on the screen. I'm going to be sharing this on the screen so that everyone can see it.
All right, so now I told all of you that it's trying to eat up the nozzle and the what? What's the second thing it's eating up? The hot bed. All right, so it's done eating up the nozzle and the hot bed. Please, can we look at this? So if you look at the temperature level now, both of them are, the nozzle is already at 215 and the hot bed is also already at 60. And now it's already commencing the printing operation. So we can bring it back up. So it's going to start printing, and then we just need to wait for that. Yeah, so just hold on. I'm going to call you back to come and see the progress while I get this correct properly. Painting the entire part. It's printing the base with it. Yeah. Very good. Oh, yeah. So 3D printing process is a very, very long process. So the part you are going to use, just send to the machine is not just going to, magically generate it in 5 minutes, right? Some of your printing process can take 8 hours. Some of them can take 2 days, okay? Depending on how big the part is. So if you are printing a very big part, please can you pass me the base, Dave, the base. So if you are printing a very big part, it's going to take even much longer. So depending on what you're printing is going to take a very long time. And that is why I'm actually printing this small part for you. And this part should take around 10 to 15 minutes to finish printing, okay? So, but this guy, for example, how many of you can guess how long it took to print this? 6 hours, okay, you're close. 9 hours, 5. All right, so this took between 8 and 9 hours to get it printed. So this is how much time the printing process takes. I will show them issues. So if you look at your screen now, I'm going to show you a correction I need to make on the G code that you gave me. Okay, so you can see my screen. If you look at what the machine is doing, it's going round. So that means it's trying to print the base. There's something we need to change in the design we've not changed. And that's why it's not just printing the link, it's also printing that big base. Even though I have removed this for those of you that have removed it from your design, it should not be there any longer. But for those of you that have not removed it from your design, it will actually try to print the base. So what I'm going to do now is that I'm going to replace what it's doing now with actually a G code that doesn't contain the base so that you can see something today. So I'm going to terminate this to restart it. Okay. This is me fixing my error here. So you might just want to again look at my. Can you see? It's to find it. All right, don't worry, you can find it. Or keep looking for it. So if you wonder what I'm doing, I'm just doing some quick maintenance so that we can have a successful print. But you don't have to worry about all of this. This is kind of great.
Shouldn't be this side. Can we pause the video?
We are getting back here. So what I just did is I had to replace the filament so that the print can actually finish, because what you have there before won't finish this print. Okay. So going back, just the normal things. So, sorry, just wait there. So you remember that I said this was trying to make a database because of the correction in your model. So I'm just going to say something that's not containing of, and we're going to be putting that instead. But it's still the same idea, just still sending a G code. So I hope we get the idea with everything we've done so far. Anybody has a question on what we've done so far? While we're waiting for the print to finish. Anybody with a question? Okay, so just keep printing. Your patience is needed when you are printing.
Okay. The guys are having issues here. They left already. All right.
What's the current closing temperature? What? 97. Where are we going? We're going to 200 now. It should be there very soon. Alright, so what's the current closing temperature? What's the current closing temperature? I want you together. What's the current closing temperature? Alright, so where are we going? So we can see from there. So what that temperature level is? The machine is going to start moving when it's going. So that's our PID. Because the focus on it doesn't there. The focus on it. So since we have reached the set temperature level, that's the French 12. Yeah, that is primary diffuser current. Primary diffuser is just trying to push out excess material before it starts printing the actual part. So now that it has moved to the center of the hot plate, printing the actual part. So we need to wait for another 10 minutes while the print finishes of the printer. Now, can you see all that nozzle? You already have a particular problem. You start seeing something like repelling. I know you can see that way. Okay, so that's what it is to keep doing over and over for each layer until finishing the actual part, right? With a very, the little bit of a slow process, it gets faster as I said, or this is going on, or this might will take this proper bigger part of the take. Right, so I want you to come around group by group so that you can see these are different stages of it. Can we have a call group, please? So that you can have a look at different stages.
Before it finishes. So you can see we have the first layer first, right? So there's like almost at 0.2 now, very, very thin layer. So that is the first one. And then after this layer, it needs to go to the next layer, right? And then over and over, it keeps doing that. It's finished meeting the entire part. So if you come back in the next 5 minutes, you're going to meet it at at something that is much higher than this. Is that okay? So you can go back now. This next group can come around to see this.
One of them can show you what we have to make it work, talk about. For the machine can generate the code after to me. Why is that? Why is he adding that to me? It's adding to so that this guy is very well on the bed. So why the data is looking right is because the data is going to ship the pattern. So it has this very wide basis on the layer on the top of the vectors that gives part of the property of we call it adhesion. Like the proper adhesion between the part and the bed. Where they are. So what are you working on this part? Bring what? The brain. All right. So we can go and come back to see the finished part. The next group, please. All right. So at the center, you can see the actual paper link. Okay. Can you see the actual paper link at the center? All right. But if you look on the just on top of the node page, you can see there's a wider part. So that wider part is what we call the brain. I said the brain is there for adhesion. It's there to hold the paper firmly to the hot bed. So that while this hot end is moving left and right, it doesn't shake, it doesn't displace the grip, it doesn't displace the actual plate on the bed. So we're going to talk about details of bed adhesion with that, but for now we don't need to consider about that. So you come back and you come and see the finished function. Let's go. Right, all your case, we're ready to launch as you can see, it's starting from plus. Okay. So the other thing we're going to do was start with we started from plus and now we've got this one. So just under the actual part, you can see a wider, something like a mass. And the object is there. So that thing that looks like a mass is called a brain. It is there to perform the function of adhesion. Adhesion in terms of holding the actual part steadily from the outside. So that when it's printed, it's holding the just track that actual part of actual position. This is all just from 3 minutes time and just to see the part. Right, the last row, or the two of them came together. All right. In the next 3 minutes, we should have the actual part finished, and then we can come back to see it. So if you look at the screen, you can see a progress bar, right? Can we see progress bar on the display? How many percent done? 74% done. And then on the right, you see how long we spent. So actually spent 3 minutes. Now spent like 2 minutes time, 3 minutes time is what we've done. All right. So this is the preferred way to design a Fusion 360, and now you have this actual you see graphs in the dream. The dream I said is not part of the actual design. So you need to do that. So you can see this is actual plastic. And you don't do that we don't support my house, that's for the research. But what is going to do that for the research? Right, so we have this group. Okay, the first group. Okay. What's the design of the research? Now, the real world. So the two diagnosis design. Okay, so that's it. Not the fine seeing out from the others. Keep watching. Come to us. Let's go, please. As you can expect with us, if it looks like exactly what you are designing, after plastic and so. No problem. So the last type of design. So you can see this is not cardboard or paper, this is actually soft plastic. So this is important. So you can use So what you're seeing is the actual direction. Remember the diameter of that meter circle was how many meters? I think 3 seconds. So if you pick up your ruler now, you pick up your ruler now, you actually need to measure it. That's supposed to be the same complete process from the design to manufacturing. Are we excited? So see you tomorrow. We'll call it a day. Thank you for your patience.